Okay, so in statistics, we talk about how to collect, analyze, interpret, and present data. That's what statistics is, right? It's how you collect data. So it's how you present data. It's how you analyze it. So think about, every time, let's say you're watching the news, and it's like some graphical representation of something comes up, right? This many percent of Americans believe blah. This many percent of Americans suffer from blah. This many, these are all statistics that people have had to, conduct surveys, collect data, analyze that data, and then how it's presented, right? Whether it's a line graph or a bar graph or a whatever, that, that depends on many of the factors of like what the study is based on, what the goal of the presentation is, and so on, right? So those are some of the things we're going to talk about. Okay, this first lesson is all about like vocabulary for statistics. So measure of central tendency is basically different ways of representing the center or the middle of the data, right? So for example, like, the minute one of your teachers grades a test, one of the first questions you ask is, what was the average, right? Because you want to, right? Because we want to know where the middle was and how we are in relation and so on. That's a type of measure of central tendency. Okay, let's talk about a few things. Population versus sample. Population is the entire membership of objects, events, people, and so on, which is to be analyzed. So for example, if it's about, I don't know, consumption of like sugar in the US, it would be the entire US population, right? A sample size, a sample is the people, let's say, who have been surveyed, right? Like when people call certain individuals, like people who are doing the survey, they will actually call certain individuals and they will say, hey, in the last week, like how much sugar have you had, and so on. Well, they're not going to call every single person who lives in the US, right? They call a group of people, that's the sample, and then we use that to extrapolate or to, make that like a general statement about the population of the US. Outliers are values that are extremely high or extremely low. So for example, if, scores on a test, let's say, were from, 80 to 87. Let's say everybody got, 80 to 87, right? One student, let's say, got like, they didn't see, that there was a second page to the test or something, and they got a 50, right? Or another person, that's an outlier because it's very far from where the rest of the data is. Okay, let's talk about some notation. This symbol is a sigma. That's actually like one of the letters in the Greek alphabet. That's a capital letter. It has the S sound, right? And we use it for sum, like when you're adding a bunch of numbers. And the way we write it is like this, okay? So that's a capital sigma. X is the variable usually used to represent individual data values, okay? N is the number of data values in the sample. So for example, if you, measured the height of like 500 people, that's, N is 500, okay? Okay, I'm gonna take 2 seconds and please take your phones, put them in your backpacks, not in your pockets or not on your chairs. Two seconds, put your phones in your backpacks, please. I don't want them in your pockets. I don't want them on your chairs. Thank you. Capital N is the data values in a population. Okay, so for example, if let's say you were conducting a survey on like, I don't know, the average height of the D. Toledo student, you're not going to measure everybody's height, are you? That's silly. So you just, you take a random, you take a sampling of, let's say you measure, the heights of 50 people, that's lowercase n. And then capital N is all of the, like the whole student body, 300, 400, whatever. Okay. Mean. Mean is also called arithmetic mean. This is what we know as the average. All right, but we don't really use average in stats. We use mean. And you know how to find average or mean. We add all the values and divide by the total number of values. Okay? Most people refer to this as average. Okay. If the data is a sample from a population, right? So like the 50 people whose heights you measured, the mean is this. It's X with a bar on top, and it's literally pronounced X bar. Okay? So the mean is the sum of all the amounts over the number of people. So it's the sum of all the heights over 50. If the data is for an entire population, then the symbol for mean is not X bar anymore. It's this symbol called mu. This is another Greek letter mu. It makes the m sound. Anybody here in physics? Yes. Have you done coefficient of friction? No. Okay, whatever. It also happens, so it's like mu. It's written like that. Okay. Mu. Okay. So that's the mean if it's the entire population. Okay. So here we go. We need to find the mean of the following set of numbers, and it's, literally just you count how many there are. In this case, there is 8 of them, so n is equal to 8. And you would literally just go in here, put all the numbers in here, and divide by 8. It's probably smartest to put the whole thing in parentheses and divide by 8 in one shot. So 14, 7, 5, 23, 9, 1, 5, 19. I did that right? Mm-hmm. Okay, so it's 83 over 8. However, okay, if you get an answer like this, just go back, press up, highlight one of them, enter, and you can do Control Enter to get the decimal, 10.4. Okay.
You don't have to even copy and paste it. You can just press Control Enter.
Not Control Enter. Just press the up button.
No, but if you do,
it just goes like answer and then.
It'll do.
Oh, yeah. Okay. So how do we show work? X bar, which is the mean, is 14 plus 7 plus 5, 23, 9, 1, 5, 19, all over 8.
We have to write this out.
Yeah. This is how you'll show work. And for these, you won't have too many, but I still, we still need to know where the answers come from. Don't worry, you're going to have a lot of opportunities where you just have to plug things into the calculator. Okay. What's the good thing about, so when you have a set of data, all right, you have, let's say, 5,000 test scores. Why is it, what are the advantages of the mean? What are the disadvantages of looking at the mean or the average? The mean is relatively reliable, okay? The mean doesn't vary as much as other, measures of center we're going to look at. And the mean is good because it takes every data value into account, right? The disadvantages of mean is that it's sensitive to every data value. Because every single value is taken into account, it's sensitive to every single one. So for example, remember that example of if everybody's test score is between 80 and 87, the average should be, somewhere around 83, 84, right? But if you also take that person who got the 50 because they didn't see the second half of the test, then the average will all of a sudden go down, right? So this is how the mean is affected dramatically by an outlier. So one extreme value can affect it dramatically. The technical term for this is, it's not a resistant measure of center. It can't resist these things, okay? All right, let's talk about median. Median is literally the middle value when the original are arranged in order of increasing or decreasing magnitude. Median is given the symbol this. Okay, you know that like button like to the far left of the one on your keyboard? Like on your computer keyboard that nobody uses? That's the tilde, like that's that little one. So that's a tilde. Yeah, and then the symbol for mean, it's also M for median. Okay, so to find the median, sort the values. That means you have to arrange them in order. You've got to arrange them in order. Then, here's what you do. If the number of data values is odd, so if you have 21 test scores, the number located exactly in the middle of the list is the median, like smack in the middle. If the number of data values is even, if you only have 20, there is no middle value, so you have to find the average of the two middle numbers. Okay? All right, let's do this one. Find the median of this sample. First thing you have to do is sort the data. Okay? So let's sort it from smallest to biggest. So we have a 1, 2 5s, a 7 and a 9. Right? What else? What's the next one?
Always the hardest one in elementary school. I swear.
And there is a 23. Yeah.
Yeah.
Okay. So how many of them are there? 8. So n is 8. That's an even number, right? So look, if you go to the middle of the data, right, that's the middle of the data, there is no number there. That means what you have to do is you have to take these two in the middle and you say x tilde is 7 plus 9 over 2. You have to take the average of the two. That's 8. So that's the median. The median is 8. So suppose these were test scores of 8 people. If the median is 8, it means half of the class scored below an 8, half of the class scored above an 8. Okay? Yeah.
For like this, when you do this, do you want to straight out the middle step of like 7 plus 9 equals over 2, or can we just write like x tilde equals 8? Is like something that's easy enough?
Once you sorted it, I think it's fine to just say x equals, yeah, it equals 8. Okay, so this one, when we sort the data, okay, so this is important because, for example, if like there is a class, right, who took a test, and if the median is like, I don't know, 85, that means half the class scored above an 85, and that's an important thing, right, because that's actually a good thing, right? Whereas like if the median was 56, it would mean half the class scored below a 56, and that's not necessarily a good thing. All right, so so we have 18, 20, 25, 26, and 38. Here, n equals 5, that's an odd number. And if you go to the middle of the data, right, because it's an odd number, there is a number there, so we say x tilde is 25. So far, so good, right? Remember doing this in like elementary school? Yeah.
This is my downfall.
Oh, no. Well, no. Now it's different because you're much older and wiser. Mode. Mode is the value that occurs with the greatest frequency, the number that shows up most often. Okay? A data can have more than one mode or no mode. And then, depending on that, we call it unimodal, bimodal, multimodal. Okay? All right. So to find the mode, you don't have to sort or anything. Just go through and see if there are any repeats of numbers. So it looks like the 1.10 happens twice. Is that it? That's it. So the mode is 1.10.
You have to write like mode equals, or can I just write one?
Okay, so you might have a question where you're being asked for more than one thing. In that case, you have to specify. But if the question says, what is the mode?
So if there's multiple, do I have to say like multimodal equals?
Okay, so take a look at this next one. No. Okay, yeah. So look, let me get to that after we do this. Okay, so take a look at this one. So there are 3 27s, there are 3 55s, 2 88s. Okay, because there are 3 of the other numbers, the 88s don't count, right? Because it's the one that happens the most often. So the mode is 27 and 55. Now, if you are also asked, so that's the mode. If you are then also asked, is this data unimodal, bimodal, multimodal, then you would say this is bimodal. That term is going to come up again when we do like some of the histograms later on. So we're just getting introduced to the vocabulary right now. Okay. Okay. Measures of variation. Oh, we skipped C. Is there a mode there? No mode. Okay. Let's go to measures of variation. This is basically a description of how spread out the data is. Okay? What we were talking about before was measures of center. We were just looking at the center, what's the mean, what's the median. Now we're talking about like how spread out is the data. One way we can look at is the range. All right, and the range, very easy. It's just the maximum minus the minimum value. Hang on, my computer just shut down. What happened here? Is it really an emergency?
Yeah.
Okay. All right. So we would like to know, like how clumped together the data is or how spread out. And the range is obviously very sensitive to extreme values, so sometimes it's not very useful. All right? Okay. So the range here, right, was 27. Okay. Now, standard deviation. This is very, very important. Very, very important, because lots of things we're going to do later is based on standard deviation. Standard deviation is basically how much values in a set differ from the mean. So for example, if the average on a test was, let's say, an 83, right? How much is everybody's test score away from the 83? That's standard deviation, okay? If they're all very, very close to the 83, that's one thing. If they're very far, that's another thing. Okay, here's the formula for standard deviation. Okay, so it's the square root of x minus x bar. Remember, x bar was the mean, that's the average. X is each of the data values. So I would take each of your test scores minus the mean squared divided by n minus 1, take a square root. Okay? Now, we're going to do a couple by hand because it's super important for you to be able to physically know exactly how to do this. And then once our data sets become bigger, we're going to learn how to do it like just with one shot in the calculator. All right? Okay. Okay, so here, so S is the sample standard deviation, sigma is the population standard deviation. All right, so what are some properties of this? Okay, standard deviation is usually positive. Standard deviation is 0 when all of the data values are the same number. Larger values indicate greater amounts of variation. And then if you have outliers, it can increase dramatically. Okay. Units of standard deviation is the same thing as the original data value. So if it's something for the height, it's in measures of height. Okay. All right. We're gonna find standard deviation for these values here. Okay, so let's go ahead and do that. First, we need to find the mean. So mean is 2 plus 8 plus 10, 12, 14, all over, how much is n? 9.2. Okay? Okay, step 2. Subtract the mean from each individual value. So, we take the first point here, 2 minus 9.2, that's 7.2. Negative. And then 8 minus 9.2, negative 1.2. 10 minus 9.2 is 0.8. 12 minus 9.2, 2.8. And then finally, 14 minus 9.2, 4.8. Okay? So what we have now is this in the formula, x minus x bar. This is your x minus x bar values. The next one out is square them. Okay, so you have x minus x bar, now you square them. So that's the thing. Square each of the standard deviations that you found here. Okay, so at this step, I always ignore the negatives. So it's 1.2 squared, right? We do all of them. 0.8 squared, 0.64. Okay. All right. So we found x minus x bar. We squared them. The next operation is the sigma. Sigma means add all of these up. Okay. So this is the next thing we're going to do. So this becomes 51.84, 1.44, 0.64, and so on. Okay. Next, divide the total. Yeah. It's just so exciting. Jenna says this equals 84.8.
Yeah.
Good. Next, we're going to divide by n minus 1. So if n equals 5, n minus 1 is equal to 4. So 84.8 divided by 4 is 21.2. And finally, we have to take a square root of this, and that's the last step. 4.6. That's crazy. Yeah. Okay. Now, let's see how you do it. Let's see how we do all of this on the calculator. Okay. So no one will have a data set of 5 points ever. Okay? Like, even if it's like a 5-person class, like no one's going to calculate the standard deviation because you know how far away each of the points are, right? So this is very unrealistic to have just 5 data points. Most of the time, we have hundreds, thousands of them, right? So what we're going to do is we're going to use the graphing calculators to find mean, median, mode, mean, median, and standard deviation. All right, so go ahead and take out your calculators, please. And go, like, oh. Right, press this, the red one here, the on button to get to this screen. And then select the spreadsheets here. Okay. In here, you're going to put in your data. And what I want you to do is,
Where's spreadsheets?
Okay, press the on button. Look. Okay, here. Okay, now let's just start with this same one of the 5, right? So let's go 2, enter, 8, enter, 10, and so on. Okay. The next step is probably one of the most important, is you have to name your list. So to do that, you can either scroll up to, you see where it says A next to it, and like click on it so that you get a cursor. And you have to name it something. So let's just name it, I don't know, list.
That's why we have a keyboard.
Yep. Enter. Okay? Because if it's unnamed, it like nothing, you can't do anything with it. Now, step 3 on this, right? We're just following along, and that's what you're going to do at home. Press menu, statistics, stat calculations, one variable statistics. It asks you this, just press OK. All right, and then press OK again. And in here, you have all of the stuff that you need. So you've got X bar is your mean. You know, you've got S is the standard deviation. Didn't we get 4.6? We got 4.6 for the standard deviation.
So I got 46. Oh, no, I didn't. Jeremy.
And then the median is the, you know, it's over there and all that stuff.
Wait, where's the median? Wait, what?
When you scroll, okay, you can scroll down and there's a whole bunch of other stuff.
So cool.
Okay, so here's what I want you to do now. Okay, here's what I want you to do now. Press the on button again. Press the on button again and click the spreadsheet button again. We're just going to get a new spreadsheet. Okay.
1.1, it's still there.
Right, but if you want it, it's still there.
Wait, why do I have a 1.2?
Yeah, I'm at
Because you're at
made a new one.
No, I'm at 1.3.
It's fine. Don't worry about it. Okay. Okay, listen. Take a look at this question. Metabolic rate is the rate at which the body consumes energy. It's measured in calories per 24 hours. During a study on diet and exercise, the metabolic rates for 2 different groups of men were observed. Which group has a higher, has a greater variation in metabolic rate?
Standard deviation.
Okay, so, well, here's what we're going to do. We're going to put group 1 into one of our lists over there. So go ahead and do that. Every single one.
Does it matter the order?
No, the order doesn't matter. That's the whole point. In one column, yes.
We don't have to go like right.
Okay, so look at what you're going to do. No, here's what you're going to do. Look. This one, enter. Press the on button and select the green button again. One vertical list for all of them. For the whole thing.
If you make one typo, you're screwed.
Yeah, that's what I was
Not really. You can just add it to the bottom. Or go up if you like type in the wrong number. Oh yeah.
Okay.
This is tedious.
so funny.
I like it.
Okay. Listen, before you do anything, right? Before you do anything, make sure you have at least the same number of the data points as what's in your table, right? So here we have a 4x5. We have 20 in here, so that's good. Okay, so let's go ahead and do the calculations here. Menu, statistics. Oh my God, see? Thank you. I know. Okay, so naming this, I'm just gonna name it A. Is that okay? Okay, so statistics, stat calculations, and you're not going to forget how to do this because whatever we're going to do, you're going to do it the same way. So look at what this is telling you. It's telling you, is this the list, right? Is it in like column A? Is this the one that you wanted, that you wanted me to work with? Yes. And then here, it's asking you, do you want me to put the results in column B? And we're telling it, okay, sure, yeah, do whatever you want. So, okay. Oh, it's okay. Just say okay, and it'll do what it wants. Okay? So, okay, so look, what we're gonna take from here is this. The mean, what's the mean?
X 1603.9.
1603.9. What's the median? Scroll down.
Median is 1591.5.
0.5. What's the standard deviation? S.
100.2.
100.2. Okay? Those are the things we're going to take. Sorry for the messy writing. Okay, now, let's...
Give you the standard deviation.
Huh?
Where's the standard deviation?
It's S right here.
It's like SX.
Okay, it's S. Now, while I take some questions, what I want you to do is this. Can everybody look up here for a minute? Press Control, and this button, the document, so it says plus page, right?
No.
Okay.
At the same time.
No. Press Control, let it go, and then press this button. It gives you this. Now it says, what do you want to add to this? We want to add another spreadsheet. This is another way to get a new spreadsheet. Okay? While I take some questions, I want you guys to put in list 2, group 2, and I want you to do the stat calculations and write down the 3 things for that list: mean, median, and standard deviation. Go. Everything. Who has the median?
1605.
I'm sorry. I swear if I had 2 more minutes in class, I would wait.
We do?
What is the standard deviation? Like 2 or more.
51.6.
Okay. Okay. There was a question about the number of decimal places. Usually we go to 1 more decimal place than the data is given in. Okay? Now, we were having so much fun, we forgot what the question was asking. Which group has a greater variation in metabolic rate? Group 1, definitely. You see how the mean and median vary from each other, whereas this is so close? And do you see how this is a much higher standard deviation than this one? So group 1 is the one that has the biggest variation, right? And you can already see, how this could come in, like handy, right? Like the new laws affected, blah, blah, blah in this state more than it did in this state, right? Like the, accident rates were, whatever, okay? All right. So, homework, there's always homework. It's on the practice test. I'm sorry, it's on the lesson plan. Okay, hang on. Okay, if you go on the lesson plan, okay, homework is from page P37, right? Because it's in chapter 0. So remember that. You're not going to go to page 37, P37, okay?
Yeah.
All right, I will see you guys next time.